Hey, what's going on, guys? Komak again here. In this video we're going to be defining the board class to keep track of the tic-tac-toe game board position state, and also we'll be using the instances of the current board class in order to associate them with the nodes of the Monte Carlo tree search move of trees, basically. So for those of you who's not aware, there is a significant difference between the Monte Carlo tree search algorithm and the Minimax algorithm, and the difference is that Monte Carlo tree search algorithm keeps the game tree in memory, and the reason for doing that is because we need to backpropagate the scores that we've achieved from the random rollouts during the search. So eventually all that data from number of nodes, number of visits for a current given node, and also the number of wins for a current given node would be used later on to calculate which particular node are we supposed to pick up eventually when it comes to actually asking the search algorithm to return the best move, assuming the current given board position. So it's much more easy, it's easier to implement and show rather than to explain. So without further ado, let's actually start writing some code. So the very first thing, we need to import a couple of packages. So here I want to say from copy, I want to import what is known as a deep copy. So deep copy like this. And the reason for doing this is the following. So we would be copying the instance of the entire board class in case if we need to generate a node for our opponent. So hope that kind of makes some sort of a sense. So I just want to open the terminal in the current working directory here, and by typing python3 tic-tac-toe.py, trying to run our script. So now also we would be importing the Monte Carlo tree search module that we'll create later on, but at the moment we don't have that, so there is nothing to import at this moment. So here we want to define the tic-tac-toe board class, and we want to define this. So I say class, and I just call this class board, and let's start with the very first initializing method. So we want literally to create a constructor. So literally initialize board class instance. Okay, so there is the standard method called init in order to achieve this, and it would be taking the self instance, and also it would be taking the board which this keyword argument board would be taken the instance of the board class when it comes to make a move for the opponent. Again, like let me just try to implement this, and then at the end of this video I'll demonstrate how exactly this would be used. So I hope that you will get an understanding of how in particular the stuff is being done here. Okay, so by default it would be equal to none, which means that we can create the board class without specifying this board right over in here. Okay, so the next thing to consider, we need to define players. So we can say self.playerx, and it would be equal to x respectively, and also self.player not. I would be using the O symbol here. It would be equal to O. Well, O here means actually 0. It doesn't matter which kind of what kind of characters to use there. So the next thing to consider, we need to define the board position, and I came up with a quite pretty tricky, but at the very end very interesting board representation as the dictionary, believe it or not. So we can say self.position, and it would be equal to the empty dictionary like this. the next thing to consider would be to actually initialize or reset our board, but as far as we don't yet have that method, I will just keep this empty at the moment. And last but not least thing here is we need to keep track if this board argument actually takes the instance of the previous board state. In that case, we need to make use of this dip copy that we've imported to actually create in this board. Instead of doing all of this stuff, we need to create a dip copy of newly taken argument there. So we want to create a copy of a previous board state if available. So sorry, like this. So I can say if board is not none. Could have say if board without is not none, because that's the same. In this case, we need to say self dot dictionary. And what in particular do we reference by saying dot and this dictionary within the underscores, within the double underscores? This means that, well, for those of you who's not aware, that in Python there is a nice little trick or hack. So in order to get all the internal fields of a given class, so this self dot and whatever. So again, like we could have say like player x equals to x, and this is the same definition. So just do it in the board class or initializing this during the constructor. The end result would be the same in both cases. Just it's the more fancy and more correct way of doing things to actually make this within this init constructor default function. So anyway, this player x, player o, and position are represented as the dictionaries, basically, as the dictionary items. So these are the values, and these are the keys, and these are the values. I'll now demonstrate you this just to make it clear on how it works. But for now, we just need to say that self dictionary would be equal to, and now I'm using this dip copy to copy the entire object that is passed here within this board keyword argument. So dip copy of board and the dictionary of that element. So let's define the main driver. Anyway, we need this main driver, and I can say if name equals to main. In this case, we want to create board instance, and I say board equals to board like this. So if we now just try to run the code, it creates the new board instance. And again, like just to give you an idea of what this sort of stuff means, let me show you this. So if I say print, and I want to print board dot and this dictionary, save, then we have the class inner fields in the format of a dictionary. Like we have the player x, player o, and the position. Well, obviously the position is now empty because we didn't yet initialize it, so we need to initialize this quite pretty soon. And in order to demonstrate how this part works, I first need to initialize the board and try to make some move on it, and then I'll show you how this sort of stuff works. So let's say let's call self dot init board, and I'm separating this function because we would be using this in other places, or would we? Well, anyway, here we want to initialize or reset the board. So def init board, and it would be only taking the self instance, and that's kind of it. So here we need to loop over board rows, for row in range of 3, because we have 3 to 3 grid in order to represent our tic-tac-toe board here. And then we need to loop over board columns. So I can say for col in the range of 3 elements. And now we want to set every board square to empty square. And again, like we could have also defined this empty square, so I'll say self dot empty square would be equal to dot, like this. So here I can simply say, so I'm referencing self dot position, so I'm referencing this position, and this is the dictionary, so we need to reference it by the key, and then we can assign the value. And interesting trick here, that in order to reference this by the key, we can simply say like row and column, and this would be the reference. So row and column would be defining the particular key to reference this position, actually. So we're kind of creating the new element, and the trick is that we can use the coordinates to easily reference the particular square on the board using this dictionary format. So this would be equal to self dot empty square. So let's try to run this to make sure no errors there. Okay, there's no empty square. Oh, what have I done? Okay, and now we have this kind of stuff being initialized already. So player x is equal to x. Okay, empty square position. So we have this 0, 0. This is the key. So we're using the coordinates as the keys of a dictionary. So 0, 1, this one, and so on and so on and so on. So another thing that we need to make here is actually, it would be nice to print the board. So print board state, and there is another nice hack in Python. So we can define the str method, and it would be taking the self instance. So the idea here is that we can simply say, we would be able to say like print board, where board is the instance, and every time we call this, it would be referenced in this particular method. So in order to avoid saying like board dot print board and all this stuff, so just compare if we just say like print or even like maybe board dot print board, it's a little bit too many text, too much of a text, so we can simply say like print board and get the jobs done. So here we want, again, like we just copy this sort of a loop, so just copy this sort of a loop here, paste, and I want to print actually whatever is available there on the board position. So I could have say like print and self dot position and row indexed by the row and column. But if we just go this sort of way, yeah, and also we want to print new line every row like this, but this won't be working in this particular way because this string method should return a string. If it doesn't, it would be giving us an error. So I just wanted to give you an idea of. So let's just try to print the word, and you'll see like what's wrong here. So string return non-string. So it should return a string actually. So in order to do this, we first need to define board string representation like this, and let's create the board string variable. It would be the type of string obviously, and here instead of printing anything, we just can say that this board string plus equals to whatever we have, and here whatever we have on the current cell, and here we want to append the new line. So here I say board str plus equals the new line character, and already it should be printing and yeah, the main stuff is also to actually return board string at the very end. So return board string like this. Okay, board string. Okay, so finally we have our board been printed. I didn't yet actually print any sort of crosses or nulls on it, but just to give you an idea, so let's say board dot position, and let's say 2 and 2 would be equal to x. So in this case it should be printing, yeah, because the index starts with a value of 0, so this 2 would be like here. So in order to make it in the center, this would be like so. But anyway, we'll make this making of the move process more user friendly by first actually type in the column and then the row. So first the x coordinate, then the y coordinate, and also so it would be like this would be the index of 1, not index of 0, like it's implemented in Python. So just to say like 1, so 1 1 here, like 2 1 here, 3 1 here, 2 2 1 here, and so on. So we'll cover that just right in the moment. But before that, before actually doing that, I also want to print the site to move. So I can say if and self dot player1 is equal to x. In this case, we need to say board string plus equals, and I just want to have, well, not plus equals, no, not like this. String plus board string to prepend. So here we want to prepend site to move to the board string. So here we can say x, or I can actually use the double quotes, x to move, save. Excuse me, player 1 doesn't have, oh, player x, I'm sorry, player x. Okay, and after we need to have, well, so first let's have a new line. Let's have some, okay, new line here, and then just want to prettify this stuff a little bit. Okay, X to move, we can make it a couple more dashes, and I want to have a couple new lines at the very end. So yeah, now it looks like exactly what we had in the demo example from the previous video, basically. So we know that now it would be X to move, and when we make a move, it would be respectively like 0 to move, not to move. Okay, guys. So anyway, the very last thing I wanted to demonstrate in this video, well, it's not yet implemented. It's just kind of dirty by hands implementation. But anyway, the second way of creating this board, the instance of our board, would be using this copy. So in order to get here within our source code, we need to actually initialize our board keyword argument. So let's say board, let's call it just board1 for a while, and it would be equal to board, and this time we want to send our initial board there. And again, like probably just to give a slightly extended to provide a slightly extended demonstration, let's say the board dot position, and let's say 0 0 would be equal to X. Save. So again, like now we should see the X. Okay, and now we would be sending this exact board state as the keyword argument to this board constructor. So we can say board1 would be equal board, but this board would be copied here using this deep copy from this particular board instance. So whatever we have in this underscore dict underscore from the board, it would be available in the dict of our board1. So if we just now print our board1, then you see like it's already been initialized from the previous kind of sort of from the previous move. And again, like the reason why this weird stuff is needed is because, assuming the Monte Carlo tree search algorithm, we need to make sure that every single board state, so this is known as a board state, this is known as a board state, so literally the board instance that not only takes the position but also who is playing with the nodes and with the crosses. And by the way, yeah, I'm sorry, it's better to call them player 1 and player 2 because they would be shifting. So player 1 would be playing X, and then the next turn would be playing with a not with a cross, and the same for the player 2. So it's better to call them like this basically. And also here, let's say player 1. Okay. And also, yeah, hold on a sec. The other thing that I forgot to do, yeah, I have forgot to switch the side, if I can call this like so. Well, anyway, let's also print the board dictionary, and same thing, board1 dictionary. Okay, so the position is the same, player, well, actually, yeah, they are the same, but we also need to, after making, well, it's already the territory of the make move function basically, so we need to change kind of side to move from X to the not, and in that case, well, actually, I think that, well, I didn't really want to implement the make move function in this initial video, but I think that we should do this just in order to understand the reason behind, well, how exactly this deep copy works, and also to finish the print board stuff, because we also would be having when the player the situation when player 1 would be equal to actually not the cross. So let's implement the make move function. So def make move, it would be taking the self instance and the coordinates. And now, interesting thing, so assuming that when we're dealing with the board initializations and printing, we're first making use of the loop over the rows and then over the columns, but it's more human friendly to actually first have the column, print in the column and then the row. So first the x coordinate and then the y coordinate. So instead of defining them like row and col, I would be defining them like col and row. And assuming that we're not going to be using the keyword arguments when calling the make move function, just for simplicity. I just make use of this order instead. So the very first thing to consider, we need to create new board instance here. So board would be equal to board like this. So we're creating the board from scratch. Take a note. Then we actually want to make move, and in order to make the move we need to say board dot position, and I'm referencing this position by this time again like row and col. We just change the order of this argument, the order of the arguments, but when it comes to actually referencing the board, I'm using this first referencing by the row and then by the column, and this would be equal to self dot player 1, and player 1 might be either x or not. So that's why we can't say like this or like this, because this would be different. So whatever value we have at the self player 1, it would be pasted here. So first time it would be x, next time it would be a not. So I hope that's clear. And the last but not least thing, we need to switch players by its places basically. So there is another hack in Python, so we can say simply like board dot player 1 and board dot player 2 would be equal to board dot player 2 and board dot player 1. So I hope this is clear. And at the very end, eventually we need to return new board state. And again, like not only the new state is differs from the previous one, not only with the fact that we have either cross or not being placed on the board, but also we switch the players. We swap the players. So let's better call this swap the players. Swap players. Okay, and just to return this newly created board. Okay, so now this should be making a bit more sense. So yeah, board dictionary would be here. So let's say, so here just a demo. So I want to make move on board, and well, for this purpose I don't even need to create the board state like this. Well, no, actually I need to call this make move. Okay, so I can say like board equals, so whatever would be returned from what I write now would be assigned to the board, and this would be the new instance of the board class. So we can say board.makeMove, and now the coordinates. Well, another little trick could have been, probably I forgot to just or on the other hand, yeah, as far as it doesn't deal, or hold on a sec, I think we can even, yeah, even here I don't actually need to swap this. I can still call keep them roll and column, and I would be swapping them on the user input stage. Yeah, so it's just a matter of input. So I would probably leave everything like row first and column next. Yeah, so by simply typing, say, 0, 0, it should, in theory, make a move on the top left corner of the tic-tac-toe board. So let's have a look. Okay, so we got this move being done. Good. Okay, I'm a bit confused by... hold on a sec. So I just want to print the initial board state first. So here, print initial board state. Okay. So we have this x to move, and we have this player 1 equals to x. It's the exact case that we cover in our print board function, but we don't yet cover the situation when player 1 would be equal to O or not, right? So this is not yet covered. So this has been changed. So let's actually cover this one. So I say elif self player 1 is equal to null, like this. In this case, I want to say not to move. Okay, so let's have a look. So we have this initial board state, so we have x to move, and just to prove that, we have player 1 equal to x, player 2 equals to not, empty square, well, that's all the same, and here is the initial board state, every cell is equal to empty square here. Then we just made a move, probably, I also do cover, to print the stuff here, so print board state after move has been made on board. Okay, and so here we have, okay, yeah, player 1 and player 2 has been swapped, so now player 1 equals to not and player 2 equals to x to cross. Okay, and also we have updated the board state, so here it is represented, and here we already have the copy of this sort of a board where we made a move, so of this board. So here we actually want to create another, let's say, it's better to call this create opponents board instance. And again, like this might seem completely unnecessary at this moment, but you will see like how we would be making use of this, of creating a new instance when it comes to associate the new instance with a specific node of the Monte Carlo tree search game tree. So here, well, the dictionary is actually the same because we did make a deep copy from this dictionary to this one, so they are literally the same. But already, whatever we do with this one, with this copy, this would remain the same. So when it comes to the actual process of searching, we'll need to go through the simulation, which means like make move for each side until we get to the state of to the terminal state of the game when it's either the win or a draw, and then we'll need to kind of get back to the initial position to try some other variations. So as far as we don't really have take back kind of function here, right? So we only have this make move function. Like in chess, you remember, like we have both make move and then take back to restore the board state. So in this implementation, the matter of restoring the board state would be the matter of using the previous instance of the board before the opponent has made a move. So that's the idea of how this stuff is going to get used. So try to feel free to play around with creating the board instances to make sure that you exactly understand how it works. And again, just to emphasize one last time, so when we create in the it's the matter of when we want to work with the opponent's move, whatever we do with that move, searching or whatever we're doing with that move, we need to make sure that we're working with a copy of the board. So as far as that copy drops, we just have the previous state of the chessboard, not the chessboard, the tic-tac-toe board. So again, like just two ways of defining the board. The initial way, when we don't specify, when the position doesn't inherit from the previous position. Yeah, probably that's the best way to call it. So the board class can create the instance from scratch, and it also can create the instance that inherits from the previous move being made on the board. And that's the difference. And again, like this would start making sense when we would be implementing the Monte Carlo tree search algorithm, and I will emphasize this again when it comes to that point. So at the moment, you just need to make sure that you understand how the copy is created and how the instance from scratch are created and what's the difference. So in the instance from scratch, we initialize the values. In the deep copy, we just copying the inner class fields. And in order to obtain this kind of difference, we're using this make move function that not only sets to the board whatever value we have where the player one holds, that the player one inner field holds, but above that, we also on top of that, we also need to swap the players. So player one starts being player two starts being player one. So that's kind of it. And also, well, obviously the print board just allows to keep track of these changes being made. So eventually, I think that we can actually drop this duplication. Okay, and now we have this X to move, and also not to move, cross to move, and not to move. But this not or O, I'm not sure if I pronounced the not correctly. It's like crosses and knots and crosses. I'm not sure. It's not the like not something. It's not. It's N-A-U-G-H-T. That's how it's spelled. Not. Okay. So, and again, like when it comes to the opponent's response, we are already working with a copy of the board. So you just take it, and I hope it really comes more clear further on. Well, okay guys, so this is it from my side regarding the very first part, and in the next video we will keep adding some key methods to our board class. So eventually first we'll create the loop that would be allowing to play in human versus human mode. And then we'll implement the Monte Carlo tree search algorithm, and then we'll apply that Monte Carlo tree search algorithm to this human versus human loop, and we will alter it so we would be playing versus AI instead of playing versus our own selves. I hope that makes sense. I hope to see you in the next tutorials in this series. Until that time, and take care.